Okay, so today we're going to look at subelement E3, radio wave propagation. There are 3 exam questions on this out of 3 subgroups. So E3A is going to cover electromagnetic waves, Earth-Moon-Earth communications, meteor scatter, microwave tropospheric and scatter propagation, aurora propagation, ionospheric propagation, changes over the day, and circular polarization. So E3A1, what is the approximate maximum separation measured along the surface of the Earth between 2 stations communicating by Earth-Moon-Earth? That's going to be 12,000 miles. And the caveat here is that the moon has to be visible by both stations. E3A02, what characterizes libration fading on an EME signal? And that's going to be when you have a fluttery, irregular fading. E3A03, when scheduling Earth-Moon-Earth contacts, which of these conditions will generally result in the least path loss? And that's going to be when the moon is at perigee. And perigee is when the moon orbit is closest to the Earth. E3A04, what do Hepburn maps predict? That's going to predict the probability of tropospheric propagation. So just a reminder, the troposphere is the lowest portion of the Earth's atmosphere, extending from the surface to approximately 4 to 12 miles above it. And under certain conditions, signals in the VHF and UHF frequency bands can propagate over great distances through the troposphere due to a phenomenon called tropospheric ducting. Canadian meteorologist William Hepburn developed a method for predicting tropospheric ducting and provides forecasts which are available on the internet using this method, which predicts signal strength propagation as a result from ducting phenomenon. And this is something that you'll see sometimes where there was a great story, I think Dave Kassler told it, where he thought he was talking into his local repeater, and I believe he was in Biloxi, Mississippi at the time, and it turns out that he was actually talking into a repeater in Tampa, Florida, because of tropospheric ducting. So you can get some real interesting effects with that and some really long distance contacts.
Can you move your screen up so we'll see the next question, or the next, like the E3A02, the next one, E3A03?
The slides are already set. You should be seeing everything.
I only see three. I see the starting E3A, and then E3A01, E3A02, and that's it.
Yeah. The next page will have E3A03 and 4. And then E3A05. So tropospheric propagation of microwave signals often occurs in association with what phenomenon? And that's going to be warm and cold fronts. E3A06. What might help to restore contact when DX signals become too weak to copy across the entire HF band a few hours after sunset? And the way to counteract that is to switch to a lower frequency HF band. So if 20 meters starts to fade out, you can switch down to 40, and a lot of times 40 will be a little more active than 20. E3A07, atmospheric ducts capable of propagating microwave signals often form over what geographic feature? And that's going to be bodies of water. So a good example of that would be Lake Pontchartrain. E3A08, when a meteor strikes the Earth's atmosphere, a cylindrical region of free electrons is formed at what layer in the ionosphere? and that's going to be at the E layer. E3A09, which of the following frequency ranges is most suited for meteor scatter communications? That's going to be 28 megahertz to 148 megahertz. So the 10 meter band through the 2 meter band. E3A010, which type of atmospheric structure can create a path for microwave propagation? And that's going to be temperature inversion. And, going back to that earlier question, temperature inversion, you're going to see that when you have fronts moving through. E3A11, what is the typical range for tropospheric propagation of microwave signals? That's going to be 100 to 300 miles. E3A12, what is the cause of auroral activity? And that's going to be the interaction of the E layer of charged particles from the sun with the Earth's magnetic field. E3A13, which of these emission modes is best for auroral propagation? And that's going to be CW, good old Morse code. E3A14, what is meant by circularly polarized electromagnetic waves? And that's going to be an electromagnetic wave that has a rotating electric field. And you'll have either left-hand polarized or right-hand polarized, depending on which direction it's rotating. Okay, moving on to section E3B, transequatorial propagation, long path, gray line, ordinary and extraordinary waves, chordal hop, and sporadic E mechanisms. E3B01, what is transequatorial propagation? That's going to be propagation between two mid-latitude points at approximately the same distance north and south of the magnetic equator. E3B02, what is the approximate maximum range for signals using transequatorial propagation? That's going to be 5,000 miles. E3B03, what is the best time of day for transequatorial propagation? That's going to be in the afternoon or early evening. E3B04, what is meant by the terms extraordinary and ordinary waves? That's going to be independent waves created by in the ionosphere that are elliptically polarized. And these are caused by the scattering of electromagnetic radiation during propagation through the ionosphere. E3B05, which amateur bands typically support long path propagation? And that's going to be the HF bands, 160 meters to 10 meters. The higher HF frequencies above 20 meters are dependent upon the solar cycle and solar activity. E3B06, which of the following amateur bands most frequently provides long path propagation? And that's going to be 20 meters. Even when you're in low solar cycles or the bottom of the solar cycle, 20 meters usually will be at least partially open during the day. And that's going to give you the best opportunity for long path propagation. E3B07, what happens to linearly polarized radio waves that split into ordinary and extraordinary waves in the ionosphere? And what happens there is they're going to become elliptically polarized. E3B08, what is the term for the long path opening that exists between 2 points on the Earth which are simultaneously near sunrise and sunset? And that's going to be gray line. And gray line is, you'll usually experience gray line right before and right after sunrise and right before and right after sunset. And if you look at a map of gray line, it's fairly amazing what you're able to work during gray line periods. E3B09. At what time of the year is sporadic E propagation most likely to occur? And that's going to be around the solstices, especially during the summer solstice. Solstices happen 2 times a year, the summer solstice and the winter solstice, and that's when the sun reaches its highest and lowest point in the sky at noon. And those are also going to be the days that are longest and shortest. E3B10. Why is quartal hot propagation desirable? The signal experiences less loss compared to multi-hop using Earth as a reflector. And quartal hot propagation is a propagation mode involving the daylight F2 layer and the nighttime F layer, where the signal does not touch Earth's surface, but reflects off the F layer. E3B11. At what time of day can sporadic E propagation occur? And that can happen at any time. E3B12. What is the primary characteristic of quartal hot propagation? And that's going to be successive ionospheric refractions without an intermediate reflection from the ground. So basically, the electromagnetic wave kind of gets caught up between layers of the ionosphere and can propagate over before it actually comes down and reaches Earth. Okay, E3C, radio horizon, ground wave, propagation prediction techniques and modeling, effects of space weather parameters on propagation. So E3C01. What does the radio communication term ray tracing describe? And that's modeling a radio wave's path through the ionosphere. And ray tracing is a method for calculating the path of waves or particles through a system with regions of varying propagation velocity, absorption characteristics, and reflecting surfaces. E3CO2. What is indicated by a rising A or K index? And that indicates increasing disruption of the geomagnetic field. And the geomagnetic field, that's going to be the Earth's magnetic field. It extends from the Earth's interior out into space, where it can interact with the solar wind or a stream of charged particles emanating from the sun. E3CO3. Which of the following signal paths is most likely to experience high levels of absorption when the A index or K index is elevated? And that's going to be polar, the polar path. E3CO4. What does the value of BZ, B sub Z, represent? And that's going to represent the direction and strength of the interplanetary magnetic field. E3CO5. What orientation of B sub Z increases the likelihood that incoming particles from the sun will cause disturbed conditions? And that's going to be when it's southward. South pointing B sub Z's often herald widespread auroras triggered by solar wind gusts or coronal mass ejections that can inject energy into the planet's magnetosphere. E3CO6. By how much does VHF radio horizon distance exceed the geometric horizon? And that's going to be by approximately 15% of the distance. E3CO7. Which of the following descriptors indicates the greatest solar flare intensity? and that's going to be class X. E3CO8. What does the space weather term G5 mean? And that's going to be an extreme geomagnetic storm. A geomagnetic storm is a disturbance in the geomagnetic field caused by gusts in the solar wind that blows by Earth and measured by a scale from 1 to 5, where 1 is minor and 5 is extreme. E3CO9. How does the intensity of an X3 flare compare to that of an X2 flare? And that's going to be a factor of 50% greater. The solar flare is a sudden flash of increased brightness on the sun. So an X2 flare is twice the strength of an X1 flare. And an X3 flare is 3 times as powerful as an X1, but only 50% more powerful than an X2. E3C10. What does a 304 angstrom solar parameter measure? That measures UV emissions at 304 angstroms correlated to the solar flux index. And 304A can be thought of as 304 angstroms in the ultraviolet light spectrum, which is 100 to 4,000 angstroms. The solar flux index is measured in solar flux units. And the solar flux index is defined as the amount of flux or radio noise emitted at 2,800 megahertz. E3C11. What does VOACAP software model? And that's going to model HF propagation. And VOACAP, which is short for Voice of America Coverage Analysis Program. It's a free professional high frequency HF propagation prediction software from NTIA ITS. It was originally developed for the Voice of America. And the National Telecommunications and Information Administration, ITS, is the Institute for Telecommunications Sciences. And it's really useful if you're, say, there's a DX station or a DXpedition that you're trying to work, and you can use VOACAP to predict the best band and times that you want to try to make that contact. E3C12. How does the maximum range of ground wave propagation change when the signal frequency is increased? And it's going to decrease. E3C13. What type of polarization is best for ground wave propagation? And that's going to be vertical. EC14. Why does a radio path horizon distance exceed the geometric horizon? And that's due to downward bending due to density variations in the atmosphere. E3C15. What might be indicated by a sudden rise in radio background noise across a large portion of the HF spectrum? And that is a solar flare has occurred. And that is it for this section. It is actually a fairly short section. And I'm going to go ahead and exit out of here. And we can go through the practice questions real quick. So E3A. So what is the approximate maximum separation measured along the surface of the Earth between two stations communicating by EME?
12,000.
C.
Yeah, correct. C. What characterizes libration fading from an EME signal?
D.
D. E.
D, correct. When scheduling EME contacts, which of these conditions will generally result in the least path loss?
C. C.
Yeah, that's going to be C, Charlie. What do Hepburn maps predict?
A. A.
Yeah, A. Tropospheric propagation of microwave signals often occurs in association with what phenomenon?
A.
Yeah, A. What might help to restore contact when DX signals become too weak to copy across an entire HF band a few hours after sunset?
D. D.
Yeah, go to the lower band. Atmospheric ducts capable of propagating microwave signals often form over what geographic feature?
B.
Yeah, B. When a meteor strikes the Earth's atmosphere, a cylindrical region of free electrons is formed at what layer of the ionosphere?
Answer D. The letter D. Option D.
Yeah,
The E layer. Good gracious.
E layer. Which of the following frequency ranges is most suited for meteor scatter communications?
C. C.
Yeah, 10 meters to 2 meters. Which type of atmospheric structure can create a path for microwave propagation?
B. B. B.
Yeah, temperature inversion. What is a typical range for tropospheric propagation of microwave signals?
A.
Yeah, A. What is the cause of auroral activity?
B. 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 B.
B, bravo. Which of these emissions modes is best for auroral propagation?
C. C. C.
Yeah, that's going to be CW. What is meant by circularly polarized electromagnetic waves?
C. 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 C.
C, yes. Okay. So what is transequatorial propagation?
C.
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 What is the approximate maximum range for signals using transequatorial propagation?
B.
Yeah, B, 5,000 miles. What is the best time of day for transequatorial propagation?
B. B.
Yeah, B. What is meant by the terms extraordinary and ordinary waves?
A.
Yeah, that's going to be A. Which amateur bands typically support long path propagation?
B.
Yeah, B. Which of the following amateur bands most frequently provides long path propagation?
D. Delta. D.
Yeah, 20 meters. What happens to linearly polarized radio waves that split into ordinary and extraordinary waves in the ionosphere?
D. D. Delta.
Yeah, delta. What is the term for the long path opening that exists between 2 points on the Earth, which are simultaneously near sunrise and sunset?
A.
Yeah, gray line. At what time of the year is sporadic E propagation most likely to occur?
B. Summer solstice.
Yeah, summer solstice. Why is chordal hop propagation desirable?
So it never touches the surface.
Yeah, A. At what time of the day can sporadic E propagation occur?
B.
Yeah, B, anytime. What is the primary characteristic of chordal hop propagation?
B.
Yeah, B. Okay. All right, last section. What does a radio communication term ray tracing describe?
C.
Yeah, C. What is indicated by a rising A or K index?
A.
Yeah, that's going to be A. Which of the following signal paths is most likely to experience high levels of absorption when the A index or K index is elevated?
B.
Yeah, B, polar. What does the value of B sub Z represent?
A.
Yeah, that's going to be A. What orientation of B sub Z increases the likelihood that incoming particles from the sun will cause disturbed conditions?
Southward.
Yeah, that's going to be southward. By how much does a UHF VHF radio horizon distance exceed the geometric horizon?
15%. C.
Yeah, C, 15%. Which of the following descriptors indicates the greatest solar flare intensity?
X. A.
Yeah, the X, class X. What does the space weather term G5 mean?
A.
Yeah, an extreme geomagnetic storm. How does the intensity of an X3 flare compare to that of an X2 flare?
C.
50% greater.
No, I guess not, because of 1 to 3, 1 to 2.
What does the 304A solar parameter measure?
B.
Yeah, B. What does VOACAP software model?
HF
H.
propagation.
B.
Yeah, B, HF propagation. How does the maximum range of ground wave propagation change when the signal frequency is increased?
Decreases. B.
Decreases.
Yeah, B, it's in a decrease. What type of polarization is best for ground wave propagation?
Vertical.
D. Vertical.
Yeah, vertical. Why does the radio path horizon distance exceed the geometric horizon?
C.
That's going to be C.
Mhm.
What might be indicated by a sudden rise in radio background noise across a large portion of the HF spectrum?
A.
Or flare.
Yeah, a solar flare. Okay. Does anybody have any questions on what we covered this evening? I know this was a short section. Looking at our schedule for next week, George, you're on tap for sub-element 4, which is amateur practices. Has anybody heard from Gene?
I did tonight. He's having internet trouble. He was on and then it stopped and he tried to get back on. And I don't know if he's not a happy camper right now. So his internet problems and that and skipping a few lessons. So I don't know. To be honest with you, I don't know if he can continue or not. We'll have to wait and see.
Okay, well, hopefully we'll hear something good from Gene coming up.
Chris, I may be hallucinating, but I swear I saw him appear tonight briefly and then he went away.
Well, he did. He came on and then it froze up on him and he tried to go back. He's having internet problems. So he went back and started over again. And I haven't seen him come up. So I don't know, obviously he probably wasn't able to correct the internet problems and he didn't get on tonight. But I have talked to him during the week and everything. And he's, like I say, he's not a happy camper. So I'm going to let him talk to Chris on what he wants to do. But like I say, I don't think he's real enthusiastic about it right now.
I've had problems with Cox. They will go down for, I don't know, minutes, not hours, but I have had them be intermittent. The most prominent of which was during the Saints football game. Fortunately, whatever they planned to take out of service, they did during halftime.
Oh,
he lost it in the storm big time, and they had to come out and they came out a couple of times and he's threatened to put a dish on the roof, but that it still didn't change the situation. And it's intermittent. It was working all day today, he said. And I had called him and I got a frozen spot during the transmission. I had to go turn it off and turn it back on and that's why I asked you about whether the sheets were moving or not. Well,
Yeah.
Mine weren't moving. Everybody else's was. So I called him on the phone and that's when he told me everybody's frozen and I turned it off and I don't think I can get it back on. And I'm not, he said, I'm not, like he said, I'm not real enthusiastic right now to finish up, but maybe we can talk him into it,
Yeah, because he's got that electronics background that I think would be extremely beneficial for all of us to learn from. I lost the coax between the utility pole and the house, and I had to put a work order in to get a new cable run. But luckily, they got it run, and other than a few dropouts when they were doing some service at the end of the street, it's been fairly steady. So that's good. It hasn't affected me doing work since I'm constantly online for that.
Well, I'm just waiting to see this big deduction they give us, this billing, because of not having internet the whole time, which is probably $5 off everybody's bill,
Yeah, probably something like that. Yeah. All right, guys, I'm going to go ahead and end the recording. And